So this is the demonstration. I've completed this prototype. This app PY, it contains all the code, and this is the symmetry logic that is going to be used for the landmark identification and landmark geometry, and also the calculation of the features, the scoring features, and so on. So let's try and run it. We'll go to the terminal. We have this environment set up that we have done with Facial Pro. So we'll just set this up and then we'll run the app. All these things, they can also be shown here in the README. If we go to the installations, if we look at the installation, we can see environment configuration. As you can see, we have to create the environment, and then we have to activate it, and then we have to install the dependencies using the requirements using the requirements txt file is in this file, and then we can have and then we can use this to run the app. I've already installed all these requirements, so that's why I can run it now, and you can see there. And then you can see the UI and stuff like that. So if I go to the terminal and run it, and we'll load up Streamlit app, you see it's all available. This is high precision diagnostic system. It's just a prototype. It has two photo overlay styles, the visualization nodes, which shows landmark points only, or either to show points and features, or only features. And it can show you like what is the face, where are the eyes, where are the lips, so that we can see if the model is actually detecting what is required. So it also has a landmark point density. It also this also has a system control detection sensitivity. So we'll try to begin with that. You can see the this person's image. You can see the pixels. We generate diagnostic overlay, and this is how the high precision diagnostic overlay looks while using the model landmark face. So basically, these you can see the eyebrows are there, eyes, nose, mouth, and lips, jaw. So if, for example, we want to see little points, we can move the landmarks, point overlay as well. So after that, it takes us to create these points. We can also create a 3D mesh, and then we can calculate asymmetry directly as well. So, for example, if we want to see the 3D mesh, we can just click over here. And this is how a 3D mesh would look like. So for example, this is the complete 3D mesh. If we look at, these are the points that are the eye area. This is the eye area. This is the nose. You can also see the lips as well. So if we go back to the overlay, this is still like, if we click here, the points and feature detection, it will show that this is the face. It shows the face, the nose, this is the jaw, this is the lips. It shows the features that are present, so we can choose. So as you can see, this is the regional breakdown. When we try calculate the asymmetry, it's the regional breakdown. This scoring methodology that we are using, it goes from 0 to 1,000. So this is severity. This severity for this guy is mild. Which is but has a good face, this guy's quite attractive, symmetrical face. And the jaw is the reason why it's such a high asymmetry. Obviously it's not perfect. If I was to give this guy a symmetry score, I'd probably give him 10 out of 10, but we can move on. It's just so mild issues, as you can see here. The person, it gives a score for each of the features, and here you can even see a chart of which feature is the most asymmetrical. So you can see the jawline has the most asymmetry. I guess one jaw is larger than the other. Here we can also click on to generate a final report. This is a CSV report. We can download the CSV report, and then we can see, just like right here, So this is the CSV that looks like this. It gives us the score for eye, eyebrows, lips, nose, and jawline, and that's pretty much it. So basically, when we move to the next patient analysis, we can upload another image in the same way, which we can do with this image two. It also gives you the amount of pixels, uh, and here's the diagnostic overlay. Um, we can also see it with the interactive mesh. It looks like this. So, for example, this is the lips, nose, and everything we've already done. You can see it looks like a face, obviously. Um, okay, so let's proceed on the analysis. This is the regional breakdown. Is also a good face, as you can see, quite symmetrical, good mid face ratios. Um, so it has less deformity score of 242 as a severity status of mild, and we can generate the final report for this one as well for points and features. We can look at here. We can click right here. Yeah, yeah. Uh, and this will generate a diagnostic overlay. So now I want to test here. I want to test a bad image, right? Someone who's highly asymmetrical. So I have the third face over here. Now let's test this with the bad image. As you can see, highly unsymmetrical, a bit unattractive, but so it generates another diagnostic overlay. Here we can see it's 3D mesh, and then we can proceed to the analysis. And for the analysis, it has overall more bad score. As you can see, it went from mild to moderate for this particular case, and this is why we have a 421 score. As you can see, very asymmetrical jawline that is crazy. As you see, it's super high. Eyebrows, eyes, and lips are quite asymmetrical, not as much as the jawline. So it's a moderate structural deviation in the face, and we can also generate a final report for this one as well. Thank you for watching my demonstration, and this is Sasigrado W1947920.